is you can get into a problem. Suppose you, let's suppose you specify the length of a run to be 365 days. Okay. When the model's in the codes running along, it reads the input for day 365, then it says, what's the next input? There isn't one, right? Because your inputs are only 360, so it's going to bomb. You're going to run that whole model, and damn it, on the very last time step, it's going to bomb. So if you want to run a 365-day model run, your input should have a day 366. That number will never be used, but when it says what's the next read, it's going to go, okay, get this on film, all right, because this one's important. It's going to go looking for that, and if it's not there, it's going to bomb on the last time step. Similarly, okay, so be it. Another option, I'm going to get deep in the weeds, but I'll go to another option. When we run, let's say, a 10-year model run, we have 10 load input files, one for each year. Doesn't have to be that way. Does not have to. We could have all 10 years in one file, but we run 10 years. We have 10 independent files. And they each have the appropriate number of days. For the moment, let's say 365. The way the code works is when it hits an end of file, it goes to open another file. Okay, so when it hits day 365 of year one, and it goes to read another one, what it really says is, I need to open the next file. I need to open the next file. I need to open the next file. So a second option, and we always do this, is if you're running 10 years, have 11 files. It's just like I said, you could have a day 366 in that the last file could have a day 366, or you could tell it there's 11 files, and the code will go and open that 11th file, it'll read the first day, and it'll run to completion. It'll never use it, but it's going to try to read it. And I can't tell you how many times, well, at this point, I know enough to do this, but even some of the experienced users, this vexes me, and on occasion we make this mistake. So I think this is documented in the manual, but I really want to emphasize it to the class. Pass that information along. You need that one extra input. Okay? Questions, comments? Go ahead, Jim.
If you're doing 10 years, just to make sure, that last file would be like 3650, right? Okay, because you were saying 365. So it's like time does continue, it doesn't reset itself at day one. Okay. But you could always put a value of like 9999 in your last record, which you'll never ever get to.
You can do anything. Yeah, I say make it 366. You can make it 367. You can make it 1,000. But you need to have a line of input that it will.
So when the program reads in two values, does it do linear interpolation or?
Excuse me?
Does it do linear interpolation or?
I'm about to sneeze. Which comes first? Okay. As a rule, it simply updates. For boundary conditions, you have the option of interpolating. Okay. But for loads or hydrodynamics or that sort of thing, no. It's a constant value until you read another one.
Okay, constant value.
We're going to talk about this again, but I'll emphasize it also, as Jim mentioned to us a few moments ago, values are held until they're updated. Let's keep that in mind. You'll get into trouble. So if you have intermittent things like intermittent loads, as Jim mentioned, suppose we had a load on day 0 and on day 1 and day 30. We get that load on day 1. It's going to stay there until we read a new one. So if you only had a load on day 1, you would want to read 0 for day 2. And then it would hold 0 until it got updated on 30. But if you don't put that 0 in there, you're going to have that load every single day until you update it. So values are held until they're updated. That's a nuance, okay? Okay, well, here we go. Was I going to look at something? All right, well, we'll look at some files in a minute. External loads files. You have 3 files in which you can specify loads. We call them S1, S2, and S3, source 1, source 2, source 3. You can turn it on and off. Let's see if I can come over to here for a minute. Yeah, this one, right, this line right here. So you have S1, S2, S3. Those are load files. The format of those files is identical. The reason you have 3 is partly it allows you to specify, for example, different intervals. Like if I had daily loads to the system from the watershed model, but only monthly loads for point sources, which is very common, I can have an S1 file for the watershed loads, which has daily inputs, and I can have an S2 file for point sources, which has monthly inputs. It also allows you to separate different kinds of inputs. I've just illustrated, for example, the idea that you could separate point and distributed flows. The Bay program gives us atmospheric loads to the water surface. They're daily. So the frequency is the same as the watershed model, but they're different. So I read them in different files. So, you know, they're just arbitrary, but you have 3 of them. Okay, we'll talk about a couple of things. You can have multiple inputs into single cells. So in the load file, you could load cell number 2 twice. You could also load cell number 2 in file S1, S2, and S3. You know, you have that option. In red, what you know, I was ahead of myself. Once specified, loads are held constant until updated. Okay. The total number of loads and their location, which are going to be specified, we're going to take a look at this file in a minute. It can only be altered by reading a new input file. You know, if you tell it at the beginning that I have 100 loads and they go to these cells, you can only change that by reading a new input file. You can't change it in the middle. We rarely do it. I just, you know, somehow, usually what we do is, you know, if we have 11,000 loads in the year 1, we're going to have 11,000 loads in year 2, we're going to have 11,000 loads in year 3, even if there's 0. I don't really like the idea of changing that number and location in the middle of a run. It's just a personal preference, but, you know, I tend to keep them constant. Let's see. So, because we're here, let's see what we got. So here now, this is a S1 file from the 30-box model. This is a file that you have. You'll notice now what we had to do is remember that the dimension, there are 36 model variables potentially. You need to specify the number of loads for all 36. Even if it's not active, it doesn't matter. It's just the way it is. So you need to specify the number of loads for all 36 variables. So there you have it. You'll see here that the next field, this is how many loads there are. In this case, there's only 1. What this is effectively more or less the Susquehanna River in this file. Okay, you know, we're scaled, sort of scaled for the bay. We have 1 load. So after you tell it how many, you have to tell it where. I could show you this file for the Bay program where we have thousands of loads, you know, but, you know, now, there's no load for temperature, so I don't tell it where. But you notice that I still have this tidal line, a line which would have where they are, and a blank. If we had 11,000 loads, you know, you'd have 11,000 and a blank. But the minimum is, even if the variable is, you know, has no load, you have to have, it's going to read this line. And I don't know what to say except that that's the way it is. So there's no load of salt. So basically, you know, I've just got 3 blanks. Now we get to fixed solids. Now, you've got 1 load of solids, and it comes into box 1. Okay, so that's how it goes. Cyanobacteria, those are those freshwater algae. There's no load, so it's blank. The next one where we actually have anything is probably over there, variable number 9 or so, labile dissolved organic carbon. Okay, and this comes into box 1. Now you want to get, everybody who wants to get really confused, raise your hand. All right, come on, okay. I'm going to explain the way it is, and I'm going to say why. I told you need 36 of these. But come down to here, we haven't got 36. We only have the variables that are turned on. And this is written in that PowerPoint, it's written in the manual. So, you know, we'll explain this and explain it and explain it. The variables that are turned on are required. Even if there's no load, if it's on, you must specify these. So there's no temperature load, but we need a line because temperature is on. Now you noticed, for example, I think that in the code I said that zooplankton don't exist anymore. Or let's put it this way, we're not running zooplankton, you know. You'll notice there's nothing in here for zooplankton. You know, I need the 36 specifications up here, but here I only use active state variables. Yeah, I see the face, you know, it's confusing. Again, I guess that's one of the reasons we're offering this course, so some of these nuances come across. And it is documented, but, you know, I'm just repeating it for you.
So what this does is, in a sense, prevents you from dynamically turning on and off state variables, because otherwise you have to add or subtract records from your files. Okay.
So this is header information. It tells you, again, how many loads do you have and where are they? And then you come down to actually specifying the load. So again, temperature, you know, these are the active variables. Once again, there's no temperature load, but it's going to look for a record, if you will, for every active variable. So, you know, temperature and salt, you see, are, you know, I just give it a 0 load. It doesn't matter, but it's going to look to read that record. Fixed solids.
And you have to have one for day 0.
Excuse me?
You need a day 0 load,
Yeah.
which would be before the beginning of the...
No.
0 is the first. Okay.
Model time starts at 0.
Okay.
It doesn't start, so that, all right, model time starts at 0. So you have to give it the first load at 0 time. That's really the first day of your model run, but it's time 0. And the elapsed time, it keeps track of time, I think, in seconds. So that's why you know, 0 seconds into your model run, you give it the first load. Okay, now we come to fixed solids. All right, this looks funky. Once again, we're hung up with formats. These are formatted, how many records is that? 1, 2, 3, 4. These are formatted F8 point something. At this point, that's really a headache. And if I had it to do over, or I think even I might do it anyway. You know, having that format here is a real pain in the neck. This makes it obscure to read, but even reading it is, go ahead, Jim.
Yeah, I was gonna, you know, it is the 8 fields, but you could put down 2.0 to whatever that is, because that will override the existing format.
Yeah.
So you're okay on that.
In fact, that's what we do.
Okay.
The reason I say it's a pain is that for some of the loads, they claim that they have accuracy out to, you know, when we get the loads from the watershed model, they don't come to us as 1.3, you know, they actually come to us as, and some of those loads are immense, you know, so.
But floating point number is only 6 significant digits anyhow. So even if they give it to you in 12, it's only going to pay attention to the 6 significant ones. But anyhow.
If I were doing it over again, this would be free formatted. I'll stop there. I suspect the reason this was done as it is Tom wanted to make this file easy to inspect. And if you've got a 30 box model, you can inspect this file. You can make entries into it, you can edit it. When you start talking about 11,000, you know what I mean? Yeah, you can't inspect it anyway. At times you can't even edit it, you know what I mean? So in retrospect, I would do this differently, but for today, it is what it is. So basically, what we've done is we've told it how many loads, we've told it where the loads are, now we're actually telling it the loads. And you'll notice, just by coincidence, for the 30 box model, I update every 30 days or something like that. So on day 0, it sets these loads. It keeps those loads constant until day 30.4. And let's see. Yeah, okay. So what's going to happen with this file, you'll see that the last, is that right? Yeah, well, okay.
Look.
Okay. I won't go into that. I may have a little problem with this one, but in any event, okay, yeah, I see what's happening. Okay.